Okay, so now that we have this in the my bond graph over here with the drawn, and then I have the constitutive equations in here. I have 4 different perform with this. Now in here you have the 4 equations, this one, this one, this one, and the bottom one that are the equations on the Cauchy form. So what I would like to do now is I am going to maybe minimize this window in here. I need to keep my bond graph model. I don't need any of these instructions. I just need the bond graph model. I am going to go and then go to the CAMPG software right here, and then go to a window in here and create a new model in here. I'm going to create a new model so that I will lower this, and that's all I need in here. See, I need to build this thing. So I am going to put the SF down here first, and I will use the same sequence and the same numbers that I have. SF in here, then I would put the 1 junction over here, and then I will do this for 1, then I'm going to put the 0 over here, and then do this for number 2, and then number 3 is to the right with this 1, so and then number 4 is with the C element, right? So we put the C element over here, and this becomes number 4, and then 5 it goes to a 1 over here, and that is this one like that, and then you have the SC for number 6, which is from here to here, and then we have the I for number 7, which is from here to here, and then you have this 0 with 8 from here to here, and you see it's pretty quick once we have the idea what we're doing and what we would like to do. So number 10 is the C element over here, so and we are at number 12. So this is the one that would go from here to here, and then you have an SC which would go from here to here. You see the part that is red is because it's not complete. See, right now we are back in business in here, and then we have the I element, and we are finished. The bond graph that I have on the left hand side is the one that I have on the right hand side. So I need to go here to the interface of MATLAB, yeah, and then I am going to let these 2 computer programs shake hands with each other and produce for me a computer simulation models in the time and the frequency domain. But in this case, at this point, I am interested basically in the derivation of the equations. That's what's a little bigger in here. We need to find the, okay, where do we go to the, okay, let's move this window over here, and we will put this ones in here. This is 4 files in here. This is the file that we're looking for the equation. See in here, yeah. So what we're gonna do is make it in such a way that we can look at the equations that I have now. on the left hand side, the ones I did. See these ones right here, and I compare it to the ones that I have on the right hand side. I'm not sure if I'll be there, but maybe so. Yes, I do. Okay, but I'm missing something. Oh yeah, the third column. But let's just use these two because for now, because they are easy to see. Okay, so in here you see these are the equations on the right hand side. Take a look at the F1. F1 is SF1, see, is in here, yeah? Yeah, I think maybe we'll use this other pen. Look at E sub 4. E sub 4 is right here, see, it's the same thing. E6, see, same thing. Let's try one of the F9, for example. F9 is down here. F8 minus E, and F14, P14 over I14. That's over here, see? And all these equations are the same. See, you see the dq10, that's this equation is right here, and dq sub 4 dt is that one right there, is this, and perhaps we can go a little higher. Yeah, if we do, you see the other differential equation, this one in here is dp14, this is e14 like that, and the one dp7 is e sub 7, which is right there. See, they're all in there. But now this one right here produce the equations in this other form, in the Cauchy form. See this equation right here that you see is going to be the equation dq sub 4 dt. That equation highlighted is this one. And you see dp sub 4 is going to be dq10 dt is this one. So it's right there. This equation is this one right here. See, that equation highlighted is this one. And you have dp14 is the next one that is showing in there. That one is right here, see? That equation is this. And the last one, dp7 dt, which is, where is that one? That's not dp, yeah, and the one that dq10, that's the other equation is, yeah, right here. I think I wrote it down incorrectly. This is not, I have the 7, not a 4. See, it's a 7 right here. So that shows you that we have a one-to-one correspondence of the equations in one form or the other. But what we did by hand, CAMPG does it automatically for you. And this explanation is to help you understand that the equations of the system, whether you have them in one form or the other, you can use them in computer simulation. From the bound graph model, you can use these equations. These are the equations that would be in the these equations you will finding in the CAMPG EQU equation .m. But these equations in this form, this one like this, you will find them in the CAMPG SY, different purposes. These equations are used particularly when you have nonlinear elements, because you can plug in those elements or the conditions of a connection or a control of an element. For example, an R element could be like a control valve in here, in this case, or if a semi-active suspension, if it has an active element like dampering here that is controlled, then for example this, if there was be let's say you have a control of this damper, which is the one in here, this R11. At that point you will define a function in here. The computer simulation would do that non-linearity. However, these other ones, these equations for in the Cauchy form have a different purpose. These equations are used to define the state space form of the system, which is used in the frequency domain for the design of control, body plots and things like that, frequency response analysis. But also the same thing could be done in the time domain using these equations, because these are equations that are normal equations for doing these simulations in both in the time and the frequency domain. Now, one thing as far as the exercise is asking you to do is getting these equations to the Simulink, and that is something that we will do it next in another session, another video.